This will be another video in our module 9, which will be covered on PISO. PISO, we know it is called as parallel in and serial out. So you're going to have parallel, which is all the data will be simultaneously fit into your SR shift register, and one by one your data will be shift out. Okay, so you can see input enter simultaneously into your respectively stages on the parallel lines, and MSB shifted first. Output are 1 bit at one time, so it's depending on your clocks. There is a table that you need to remember. You're going to have, if your load value is 0, it's going to load input value. So all of this value will fit into your SR when you have the load equal to 0. While if your shift is equal to 1, you're going to have shift out all the data at the clock plus pulse. If your clock is positive, then it's going to be positive. If clock is negative, then going to trigger at the negative clock. So here you can see that there is a rules note that you need to remember. MSB will be appear at the data out of your Qn minus 1. Okay, Qn minus 1, which is, this is your MSB. And then this will be your Q3 if let's say you have 4 bit. After n plus 1, which means that if you have 4 bit, 4 plus 1, which is equal to 5. After 5 clock cycle, all bits data will be lost. You can see here, it's lost everything. Okay, what will happen if you have here, this is all your clock positive and etc. If you have clock initially, it's going to be start on 0, let's say, and you can see at the first clock it will be 0 a lot, means that you're going to look into positive clock trigger. But at this side, what is the value for your shift and load? It is 0 there, so you're going to fit in all the value inside the SRG4. So when you have a parallel in, you already shift everything inside, which is 0 1 0 1. After that, you're going to it is 1 0 1 0. Okay, D3 there, so the value is 1 0 1 0. Then after that, after you have cycle 1, you go to your cycle 2, positive cycle 2, and at this stage your value is already 1 there. That's why you're going to shift out all the value of your data one by one. Okay, so how you're going to do is you're going to shift first the value of this one, and then you're going to shift this value, and then you're going to shift this value, and lastly this one will be remain at here because of going to have only 4 cycle as the normal one. So you have 1 2 3 4. Okay, you cannot start here from 0 because you need to start at this side. At this positive clock, is going to pull everything out, and this is the last LSB value. This is your LSB value. That's why it will be fitted in here. This is parallel in, serial out. Okay, so let's take a look at another example. Let's say you have here, complete the timing diagram if you have 6 bit. Okay, where you going to have the value? Normally you're going to have until this only, right? And then after that you don't have value. Okay, just remember here, because there is a note, all data bit will be lost at n+1. So that's why your data will be filled until 6 only. Okay, when you have this MSB shifted first, okay, you going to have at the positive clock, your value is lot is 0, means that your shift also 0, means that you're going to feed in everything into your SR, which is serial register 6, SRG 6. So here you feed in with 1 0 0 1 1 0. Okay, this is coming in first, right? So now you're going to check, after that you're going to go and meet another one, which is positive clock here. So at this stage the value of shift is already 1 and lot already 1 also. Then it's going to take out everything, isn't it? So this will be taken out, this will be taken out, and etc. So here first, after it's already fit in, let's say you have this stack. When you put 1 there, and then you have another one is 0, and then another one is 0, and then you have 1, and then you have 1, another one is 0. So you put into your stack, let's say, because this will be coming in first. So how you going to take it all back? So this one, after you already fill in, this will be coming out first. At here will be your 0 there. After that is followed by your value of 1. Then you're going to have another one, then you have 0 here, then you have 0, and lastly you have 1. Why we start at this side? Because at this particular clock there, you're going to take out everything, but please remember that you're going to have only 6 place there, because you're going to only occupy 6 cycle, right, for your value. So you're going to have like this. Sometimes you can also like remember, okay, this will be at the end, which is at the cycle 6. This will be at the cycle 5. This will be at the cycle 4, 3, 2, and then lastly at 1. It's depend on you how you can easily remember, but take note that everything here will be lost, as the notes here is already informed, will be lost. Okay, so that is on your PISO. Now we move to another one, which is PIPO. How about PIPO? PIPO is parallel in and parallel out. Means that you're going to be given simultaneously with all the data input, and simultaneously with your data input. So you can see here, parallel data input doesn't appear at the output. Output appear at the positive edge of the clock, depending also on your clock, right? Input and output done in the parallel, enter all inputs, bits appear on the parallel output. Example, here you have 4-bit SR. Can perform PIFO, PISO, SIPO, and CISO. What is this question? Okay, so you're going to have shift load input. When low, the data from input are loaded. This one is similar to the previous table. When high, data will be shift out all and everything. You can see here. If you have 4 bits, you're going to have until Q3. If you have 5 bits, you're going to have Q4 and etc. J and K are serial data input. Okay, this one is using the JK flip-flop. Okay, the example here is JK. First stage serial input goes to Q0. And then serial output will be at Q3. Okay, this is the example. You can see it's quite huge because when you have the JK, you need to convert the JK to the D, the parallel data input. That's why it's going to be having too many. You can see here, this JK will be a serial input later on to be your D flip-flop there. So this is your output side. When you have the positive clock, what will happen? So you're clear when you have the, okay, at this side you can see you're going to have SH. SH is shift and load input. When low, data input are loaded. Okay, where is the, at this side? This is the side when you're going to feed it with the value of your data input. But in this question, it's not given anything. But throughout this timeline diagram, you know what is the data input. So your data input will be D0, D1, D2, and D3. So here will be 1, 0, 1, 0. 1, 0, 1, 0. This is your data. Okay, it will be look like this. 0, 1, 0, 1. This will be your MSB. This will be your LSB. So now you know one thing, which is on the data input. And then you're going to pull it out everything after you might have one at the positive. Then you're going to trigger to pull out. So first of all, you can see at this side, it can perform for PIPO there. It can perform PIPO. It can be also PISO. It can be SIPO and also CISO. That is why it's mentioned here. So you have at the beginning of 0, 0 for your D0, D1, D2, and D3. What will happen? You're going to refer to your JK input. JK input you have, this one is your clear. What about the clear? There is any information, or maybe you can refer to this table. Where is the table? Not here. Well, this is just for you to having the value to turn on your SR. And for JK, you have 0, 0, and then 1, 1. And here is 0, 0. Sorry, this will be your K bar. See, I also didn't check at this side. This is K bar, so please be careful. If it's K bar, it's going to be like 0. Here will be 1, and this will be your 1. This will be your 0. 10, what happened is going to be set, and then you're going to have the value of 01 is going to be reset, and etc. So all of these output later on are referring to your JK value. For your JK value, if let's say it start with 0, okay, we start with 0, you're going to have the value of positive clock letter. You can see at this side, you're going to trigger your output, but for this it's just 1 there. 1, it will be 0. After that, going to refer to your JK value. For at this side, it's going to assume to be 0 first, and then when you have another trigger of next clock, you're going to have the value of 10. What will happen? 10 will be set, so that's why you will trigger to be set there. And then you're going to have the value of another one, which is 01. 01 will be reset, so you're going to reset until you meet your data there, data input. Then you're going to refer to your value of your data input. Second, for your Q2, Q3, Q1, Q2, Q3, you're going to do a shift. So what will be happen? You're going to shift your value here, this one. You're going to shift to another Q1. You're going to shift this to Q2, yes. And then this will be shifted to your Q3. And the others will be remain 0 because the previous one is 0. So this will be your QN. This will be your Q and plus 1, something like that. What will happen next? Because you're going to do a shift, right? And etc. So you can see serial shift, serial shift. And after you meet this one, which is negative at the positive clock there, and not negative, 0 for your lot there, you're going to have the feed in all the input parallel in. So everything will be in, and at the second one is going to be out because it's 1 already, right? So similar, so you're going to have 0 1 0 1. So at this one will be this will be LSB. LSB is here, 1 0 1 0. 1 how many clock? Clock 1 2 3 4. So for clock 4 here, you can see here, this is clock 1. After you meet to come out, I think it's clock 1. And then I think it's this one is clock 1. Please double check here, because okay, 0, yes, here will be 4. That's why you're going to have 0 1 0 1. So in this combination, you can also see you have a serial also. That's why it mentions that you're going to have also PIPO, PISO, SIPO, and CISO. Okay, that is on your PIPO and also PISO. That we move to another, which is a shift register counter. Did I want to cover in this video? I think I'm going to stop first. Later on I will come back and create another video. Okay, thank you.